Namaste, Mada, Pida, Guru, Deva. Welcome back to Pine IT Edu Plus. Today we are going to discuss decision trees in Python Part 2. Applications of decision trees. Decision trees are one of the most powerful and widely used machine learning algorithms applicable to a broad range of problems. Due to their interpretability, flexibility, and ability to handle both classification and regression tasks, decision trees are popular in various fields. Here, we will explore the key applications of decision trees across different industries. Customer segmentation and marketing. Decision trees are widely used in customer segmentation and targeted marketing. By analyzing customer features, business can identify distinct groups of customers. These segments help in creating personalized marketing strategies, increasing the likelihood of successful campaigns. Use cases. Targeted campaigns. Predicting which customers are likely to respond to a specific offer or promotion. Customer retention. Identifying at risk customers who may churn. Cross selling and upselling. Predicting the likelihood of a customer purchasing additional products based on past behavior. Example, a retail company can use decision trees to segment customers based on factors like spending habits, frequency of purchase, and browsing behavior, and the tailor personalized offer for each segment. Credit scoring and fraud detection. Decision trees are commonly used in finance and banking to assess creditworthiness and identify potential fraud. By analyzing factors like a customer's financial history, income, spending patterns, and previous defaults, decision trees can predict the likelihood of loan repayment or flag transactions as potentially fraudulent. Use cases. Credit scoring. Predicting whether a borrower is likely to repay a loan based on historical data and financial indicators. Fraud detection. Identifying fraudulent transactions based on patterns. Example, a bank may use a decision tree to predict whether an applicant will default on a loan. Based on features like income, credit history, and employment status, the model will classify applicants as high risk or low risk. Medical diagnosis and health risk prediction. In healthcare, decision trees can help in diagnosing diseases and predicting the likelihood of patients developing specific conditions. By using features such as age, gender, medical history, lifestyle choices, and symptoms, decision trees can provide a diagnosis or predict a health outcome. Use cases. Disease diagnosis. Identifying the presence of a disease based on symptoms and test results. Risk prediction. Predicting the likelihood of a person developing a condition based on medical and lifestyle data. Personalized treatment plans. Suggesting optimal treatments based on patient history and characteristics. Example, a medical institution might use decision trees to predict the likelihood of a patient having diabetes based on factors like age, BMI, and blood sugar levels. The decision trees helps doctors make quicker and more accurate diagnosis. Predictive maintenance. In industries such as manufacturing and transportation, decision trees are applied to predictive maintenance. By analyzing sensor data from machines and vehicles, decision trees can predict when a machine is likely to fail or require maintenance, allowing organizations to perform proactive repairs and reduce downtime. Use cases. Equipment failure prediction. Predicting when industrial machines, engines, or other equipments will fail based on operational data. Maintenance scheduling. Identifying when maintenance is due based on the health and performance of equipment to avoid unexpected breakdowns. Example, in a factory, decision trees can predict the likelihood of a machine malfunction based on parameters such as its age, usage frequency, temperature, and vibrations. The decision trees can suggest the best time for maintenance. Loan approval and risk assessment. In financial services, decision trees are used to assess the risk associated with granting loans and determining the approval process. Features like credit score, income level, employment status, and previous debts are considered to classify applicants as low, medium, or high risk. Use cases: loan approval, deciding whether to approve or deny loan applications based on the applicant's financial background. Risk based pricing, offering different interest rates based on the applicant's risk level, which is determined using decision trees. Example: a financial institution may use a decision tree to classify loan applicants as either eligible or ineligible based on their credit score, income, and financial history. Retail and inventory management. Decision trees are useful in predicting product demand and optimizing inventory management. They can predict when specific products are likely to sell out or become overstocked, helping business optimize stock levels and reduce waste. Use cases: demand forecasting, predicting the future demand for products based on historical sales data, seasonality, and promotional efforts. Inventory optimization, deciding how much inventory to stock considering factors like product popularity, supply chain constraints, and seasonal variations. Example: a retail chain can use decision trees to forecast the demand for a particular product based on past sales data, location, time of year, and ongoing promotions, helping them adjust stock levels accordingly. Environmental monitoring and climate predictions. Decision trees are applied in environmental science to predict environmental changes and assess the impact of various factors on climate and ecosystem. This includes predicting weather patterns, deforestation, pollution levels, and species survival. Use cases: climate modeling, predicting changes in temperature, rainfall, and weather patterns based on historical data and environmental variables. Pollution control, assessing the risk of air and water pollution and identifying patterns that lead to environmental degradation. Wildlife preservation, predicting the survival of species based on factors like habitat loss, climate change, and human activity. Example: decision trees can help predict areas most at risk for wildfires based on weather patterns, humidity, vegetation, and other factors, enabling early warnings and disaster preparedness. Supply chain optimization. In supply chain management, decision trees can help optimize various factors such as shipping routes, delivery times, and resource allocation. By analyzing factors like demand forecast, inventory levels, and supply performance, decision trees can assist in making efficient decisions. Use cases: route optimization, deciding on the best delivery route for goods based on factors like distance, traffic, and cost. Supplier selection, evaluating which suppliers offer the best terms, reliability, and quality based on historical performance data. Production scheduling, deciding when and how much of each product to produce based on demand forecasts, available resources, and production constraints. Example: a logistic company may use decision trees to optimize delivery routes, taking into account traffic patterns, fuel costs, and customer delivery windows. Sports analytics and performance prediction. Decision trees are increasingly used in sports analytics to predict player performance, game outcomes, and identify key factors contributing to a team's success. These models analyze player statistics, team composition, and historical performance. Use cases: player performance prediction, predicting the performance of players in upcoming games based on past statistics. Match outcome prediction, predicting the result of a match based on team performance metrics, player statistics, and game conditions. Injury risk prediction, predicting the likelihood of players suffering injuries based on historical injury data and performance metrics. Example: in professional sports, Team can use decision trees to predict a player's likelihood of scoring goals based on factors like past performance, playing conditions, and opponent strength. Energy consumption forecasting. Decision trees are used in energy management systems to predict energy consumption, enabling organizations to optimize usage, reduce waste, and forecast future energy needs. By analyzing factors such as historical usage, time of day, and external factors like temperature, decision trees can provide accurate forecasts. Use cases. Demand forecasting. Predicting future energy consumption for a given period, helping utility companies better plan their supply. Energy efficiency. Identifying patterns that lead to excessive energy consumption and suggesting energy saving measures. Example: a utility company can use a decision tree to predict daily energy consumption based on weather data, time of a day, and previous consumption patterns. Conclusion: decision trees are versatile and powerful tools that can be applied to a wide range of domains for classification, regression, and prediction tasks. Their ability to handle both categorical and continuous data, along with their interpretability, makes them popular across industries including finance, healthcare, retail, sports, and environmental monitoring. Model selection and cross validation. Model selection and cross validation are essential steps in machine learning pipeline. They ensure that the model we choose not only performs well on the training data but also generalizes well to new unseen data. Model selection. Model selection refers to the process of choosing the best machine learning model for a given problem from a set of candidate models. This involves comparing the performance of various algorithms based on evaluation metrics and selecting the one that best balance accuracy, interpretability, and complexity. Steps in model selection. Define the problem. Understanding the nature of the problem. Pre-process the data. Clean the data, handle missing values, encode categorical variables, and scale or normalize the features. Select candidate models. Choose a few models based on the problem and data type. Common choices include linear models, tree based models, support vector machines, k nearest neighbors, neural networks. Fourth step is train the models. Train multiple models on the same training data set. Evaluate models. Evaluate the models based on their performance metrics. Select the best model. Choose the model that provides the best generalization to unseen data. Cross validation. Cross validation is a statistical method used to estimate the skill of a machine learning model on new data. The main idea is to divide the dataset into multiple subsets, train the model on some folds, and test it on remaining fold. Key cross validation techniques: k-fold cross validation. The dataset is divided into k equally sized folds. For each fold, the model is trained on k1 folds and tested on the remaining fold. The process is repeated k times, with each fold used once as the test set. The final performance matrix is the average of the k test results. Pros: reduce bias by using the entire dataset for both training and testing. Helps in obtaining a more reliable estimate of model performance. Cons: computationally expensive because the model is trained multiple times. Stratified k-fold cross validation. In stratified k-fold, the splits are made in such a way that each fold has the same proportion of each class as in the entire dataset. This is particularly important for imbalanced datasets where one class might be underrepresented. Leave one out cross validation or LOOCV, a special case of k-fold cross-validation where k is equal to n. Model evaluation metrics. While performing cross validation, you can use various evaluation metrics depending on the type of problem. For classification, accuracy, precision, recall, F1 score, and confusion metrics. Hyperparameter tuning. Hyperparameters are settings that govern the model's learning process. Hyperparameter tuning is a crucial step to improve the model's performance. Conclusion. Model selection involves evaluating multiple machine learning models based on performance metrics to choose the best one for the task at hand. Cross validation provides a more reliable estimate of model performance by splitting the dataset into multiple subsets and training or testing the model on different data combinations. K-fold cross-validation is the most common technique, but others like stratified K-fold and leave one out are also useful depending on the data. Proper model evaluation, hyperparameter tuning, and cross-validation are key to improving the performance and generalization ability of machine learning models. That's all for today. We hope you found this tutorial informative and helpful. Detailed PDF notes available. Pay just Rs 49. Share the screenshot with video name and we will send you the notes. Google Pay number is given below. We are also providing online and offline classes on Oracle or MySQL SQL, PLSQL, Python Basics, and Python Advanced on all days from 4 am to 10 pm. For more details, please contact Mrs. Santhu Dinesh +919747006133. She will be available on WhatsApp also. If you have any feedback or suggestions for future videos, please let us know in the comments below. Your support means the world to us. For more videos and tutorials, please visit our channel Pine IT Edu Plus and subscribe. Don't forget to like, share and hit the notification bell. Thanks for watching and we will see you in the next video. Bye.